Okay guys, so now we are going to learn about abstract classes in Java. So let's create a new project for this. In IntelliJ we'll call this abstract classes. Let's press create. I'll drag over my IntelliJ here. Cool. So this follows on from the previous videos in this series. So if you haven't seen them, please do go back and complete those. Right, so what is an abstract class? An abstract class is just a normal class except for it cannot be instantiated on their own, and it has to be subclass. So it's just a normal class that has to be subclassed to be instantiated. I can't type today, guys. So what we can do is we can just demonstrate this. So let's create a class called animal, for example. So a new class, and we'll call it animal. Let's make this an abstract class. Now, obviously abstract is just a keyword that you might see, right? So abstract, it's highlighted orange. And we can put this right here. So public abstract class animal. And you'll see that the symbol over here is just changed a little bit. Oops. Symbol over here is just changed a little bit in IntelliJ just to signify that it's an abstract class that we are talking about. So abstract classes can contain abstract methods as well. So abstract functions, methods, whatever. And these are methods that don't have an implementation. Now, obviously, this is to do with method overriding and method implementing and things like that, which we covered previously. And that's the same sort of thing as like interfaces and all that stuff. Those are all covered previously in this series. So if you haven't seen those already, please do revisit them. So let's just create some stuff, right? Let's create an abstract method inside the abstract class called make a sound, right? So public, we'll make this public, abstract, void, because we're not returning anything. We can go and make a sound. So for example, an animal might make a sound, right? A tiger might make some sort of sound like a roar. But a dog might go like woof woof. So they're all different sounds, but they all fundamentally do make a sound, right? And an animal is sort of an abstract version of, it covers many different animals such as tigers, lions, dogs, cats, etc. Now, we've got this abstract method that doesn't return anything, and that will be implemented in another class, in a subclass. But what we can do, we can just have a normal method for an abstract class, right? So we'll have a normal method. Now, this isn't an abstract method, right? So we'll go public void eat food, right? So all animals eat food. And inside this, let's just go system out print. Oops. System out print. I am eating. Right? So that's an abstract class. Now let's create a subclass for this abstract class. So an example of it would be tiger, right? I don't actually know much about tigers, but hey. And obviously we are just going to extend upon this animal in this tiger. So we go space here, extends, and then animal. You can see we get this red stuff here. Ignore that for now. So what we need to do is we now need to implement the abstract method, right? So the abstract method is, if we go back to animal, is this one here, where we make a sound. Now you'll notice that this abstract void doesn't have a body, like this one does. And it's just a single line with a semicolon. That is because we haven't implemented this method yet. And we will then implement it by overriding it in this subclass here. So let's go ahead and do that. So if we press enter, now we could implement this ourselves, writing out all of the boilerplate, but we can actually go right click, generate, implement methods, then click on make a sound, and then we can press OK. And it will just generate this sort of skeleton code for us so we don't have to write that all out. Obviously it's not a lot, but it's something that makes it quicker for us. So it's annotated with override, and we can see the method name is the same, the return type is the same, but we have this body and we can actually put something inside. So let's go system out print raw. Well, I suppose that's more of like a line sort of thing. I don't know, guys. I mean, comment down below, to be honest. And you can do this for any animal of your choice, We could create one for a dog. So if we go new Java class, dog, and we can go dog extends, animal, right? And then we can go ahead, make some space, right click, generate, implement methods, click on make a sound, press OK. And then we can go woof woof, like that. So we have these two different implementations of an animal, and an animal is an abstract class. But fundamentally they both eat and they both make a sound. But this make a sound, what happens in here might be different. So for example, in a tiger, we roar, and in a dog, we go woof woof. I need to Google if tiger actually does make a roaring sound. I don't know, maybe they do. But yeah, so we have our two implementations of that. Now, let's go back to main. Let's just get rid of this comment here. And let's show you how to actually use an abstract class. So let's create a dog, for example. So if we create a dog, we go dog equals new dog, not view, new dog, like that. That's normal. And if we go dog dot, then we can see we can make a sound. So let's just make a sound with the dog. And then let's eat as well. So let's go dog dot eat food, right? So we've got a dog that makes whatever sound the dog makes and eats the food. And obviously this eat food method doesn't actually exist within dog in code, but it exists within animal. So if we go to animal, we can see that this is here, and that is what is going to run when we go dog.eat food, because it is in the superclass, which is an abstract class, meaning that we can only use this class or any functionality in this class in its subclass. So for example, we can't just go ahead and create an animal, right? Because in real life we can't just spawn in an animal. We have to specify what sort of animal it is, and there's a lot of nuance in that. So that is the purpose of an abstract class, where we say, listen, you cannot instantiate an animal alone. It has to be a subclass of animal, so tiger or dog, and that inherits the fundamental functionality of an animal. And there's room for customization as well in terms of the logic of making a sound. And you might have some things that fundamentally are the same, so you have those as normal methods rather than abstract methods. And then when we go ahead and instantiate that, we can inherit all the characteristics of an animal while having our own custom logic in our abstract method there. So let's go to main and press run. And there we go, woof woof, I am eating. Now you'll see this I am eating is actually coming from the animal itself as the abstract class, because this never changes. For example, if we changed all this dog stuff to tiger, so if we went like, delete all this, if we went like tiger equals new tiger, and if we said tiger dot make a sound and run that, we'll see that it says something that a tiger would say, right? But then we can go tiger dot eat food, which is an inherited method. And that is fundamentally the same as what dog would do, right? So hopefully that explains abstract classes. If any of that didn't make any sense, please do comment below. But if you don't understand where we have this @override business here, please do watch the previous videos on method overriding and method overloading, as well as interfaces would help as well. And yeah, see you in the next one, guys. Bye.